Hey everyone, Kyle Walker here. If you love cars, fixing things, or just want to understand your vehicle better, you're in the right place. I share hands-on tips, smart driving advice, and straight-up car talk without the fluff. Make sure to hit that like button, subscribe to the channel, and stick around till the end. You don't want to miss what's coming up. Let's get into it.
When it comes to the choice of engine oil, for example, for its routine replacement, the opinions of even experienced motorists in most cases diverge. In fact, it turns out that viscosity, the main parameter of oil, is not obvious from the point of view of its operational properties. Indeed, it is unlikely that you will be able to hear from sellers, employees of service centers and service stations, ordinary owners, of vehicles an opinion about one or another which would be absolutely identical. In fact, although viscosity is a rather abstract concept, it has quite specific physical and chemical properties, on the basis of which the accepted classification system of motor oils is built. This will be discussed in this material. Definition of oil viscosity. Even schoolchildren know that any lubricant must prevent the phenomenon of dry friction between moving and touching parts. With regard to an automobile engine, the task of oil is corresponding to reduce the friction force in the cylinder piston group, while ensuring maximum tightness of the cylinders. The solution of this task does not look trivial because the power unit has to work in a very wide temperature range from cold engine, starting in winter, to plus 300 OC. Such a mode is typical for some nodes of the warmed engine. Note that many drivers are convinced that the temperature displayed on the scale of the device measures the temperature of the engine itself. This is, of course, a misconception. The sensor measures only the temperature of the fuel, and it is really on the warmed-up engine is almost the same in the whole circuit and is about 90 degrees. Nodes of the power unit warm up differently. Accordingly, the temperature of engine oil also walks, and within a wide enough range, reaching values of about 150 OC. Since modern engines are quite complex structures, their manufacturers recommend the use of lubricants with quite specific performance characteristics. It is they that provide the highest possible efficiency of the engine by reducing the friction force, contributing to the reduction of wear of the rubbing parts under average statistical loads on the engine. And the most important of these characteristics is the viscosity of The most simple and clear definition of viscosity is the following. It is the ability of oil to maintain its fluidity under given operating conditions, remaining on the surface of the rubbing parts. It would not be difficult to achieve this if it were not for the dynamically variable temperature regime on an unheated engine. It is one, when working in normal mode, another, at increased loads, a third. It is clear that it is impossible to invent a certain universal composition that would work equally well regardless of external conditions. And in order for both automakers and consumers to be able to somehow assess the viscosity of specific oils, the Association of Automotive Engineers of the United States, SEE, has developed and implemented a classification of according to their viscosity, in accordance with certain temperature operating modes. In other words, the classification simplifies oil selection based on the preferred operating mode of the vehicle. Many drivers find it difficult to decipher the oil viscosity indicated on the marking of lubricating fluids for the engine in accordance with the SAE classification. As a rule, it begins with 1 or 2 digits, followed by the letter W, and through a dash follows another pair of digits. Let's look at what these numbers mean in terms of oil viscosity on a simple and accessible level. What stands before the letter W? The so-called low-temperature viscosity, indicating the possibility of starting the engine at a certain negative temperature. You can calculate it by subtracting the value of 40 from the specified figure. That is, 5W means that such a fluid provides trouble-free engine starting at temperatures of at least minus 40 degrees Celsius. Note that this indicator refers only to the lower temperature threshold for a cold engine, without affecting the performance of the oil used on a hot power unit. But again, oil manufacturers calculate this parameter on the basis of tests on specific engines, so it is, so to speak, average. In reality, everything depends on the specific motor, so you should be guided by the recommendations of the car manufacturer, not by the labeling. Note that if the maximum frosts in a particular region do not exceed 20 degrees C, You can use with almost any prefix because oils with an index greater than 20W are very rare on the market. The second group of figures indicates the high temperature viscosity index, but there is no direct dependence on temperature. It denotes a certain generalized parameter that characterizes the minimum/maximum viscosity of when operating in the operating temperature range, which is an average of 100 to 150 degrees Celsius. The higher this parameter is, the higher the viscosity of the oil when operating in a higher temperature range. And liquid oil will not be able to ensure the fulfillment of its direct duties to lubricate the rubbing surfaces. So the interpretation of the second pair of figures, even among specialists, causes certain disagreements, and the advice to adhere to the recommendations of automakers is even more relevant here. Main viscosity parameters. There is another misconception among many motorists. It is also connected with the interpretation of oil designation according to SAE classification. So, many drivers are convinced that if the letter W is present in the name, it is an all-season product, by analogy with tires, and that there are also purely winter and summer lubricants. As we have already noted, in reality, each oil is characterized by a pair of values that work independently of each other. To meet in the sale of without the letter W is almost impossible, although theoretically the standard allows it. Let's consider how to determine the viscosity of engine oil on the example of all the parameters that determine its characteristics. Low temperature viscosity, it indicates the pumpability of the fluid through the line at a certain sub-zero temperature. This parameter is called crankability, i.e., the ability to turn the crankshaft to start the engine. If the air temperature is below the calculated parameter, the oil will thicken to such a state that the starter simply will not cope with its task. But simply turning the crankshaft is not enough. It is necessary that at sub-zero temperatures the fluidity is maintained sufficient to quickly fill the lubrication system mains. It is believed that the oil marking indicates the number corresponding to the optimum value of pumpability. That is, 0W means that such oil at -40 degrees will be pumped through the system as quickly as possible. The pumpability is provided at temperatures 5 degrees higher. That is, the startup of a cold engine will be less heavy at -35 degrees. According to SAE classification, there are 6 gradations of low temperature, winter, viscosity, from 0W to 25W. High temperature viscosity, the viscosity grade of the engine oil, indicated after the letter index, has nothing to do with the ambient temperature. Regardless of whether it is freezing outside or 40-degree heat, this parameter is designed for more extreme temperatures, characteristic of the internal surfaces of the power unit. And if you somewhere on the expanses of the internet will meet the statement that oil 5W50 is suitable for hot regions and 5W20 for areas with a moderate climate, it is obvious nonsense. Read also, what should be the frequency of oil change in the gearbox? In other words, the very term summer oil is incorrect since we are talking about viscosity in a fairly wide temperature range, characteristic of a warmed engine. In reality, these figures refer to dynamic/kinematic viscosity values measured during tests at temperatures of 40/100/150 degrees Celsius. Kinematic viscosity refers to the density of the oil at temperatures of 40 to 100 degrees Celsius. The lower the CV, the less dense the lubricant will be. Dynamic viscosity is interpreted quite differently. It is a measure of the level of resistance of two oil surfaces moving relative to each other at a rate of 1 centimeter/second at a distance of 1 centimeter from each other, with a contact surface area of 1 centimeter too. This index is calculated by using special equipment, rotational viscometers, and shows the degree of resistance to movement of adjacent liquid layers. It has nothing to do with density. Another question that causes difficulty in understanding is in what units oil viscosity is measured. Indeed, if for low temperature and dynamic viscosity the standard unit, MPa*S, is used, then kinematic viscosity is usually measured in mm2/s. However, these are purely technical details. In general terms, high-temperature viscosity allows you to determine the thickness and strength of the oil film formed in the gaps between the rubbing surfaces of the powertrain components. According to the SAE classification, there are 5 gradations of high-temperature viscosity, from 20 to 60 in increments of 10. Viscosity index among the parameters determining the properties of is the oil viscosity index, which is often not even taken into account by specialists. However, this is an important characteristic that indicates the optimum operating temperature range in which all the above viscosity parameters remain at a level sufficient for the normal operation of the power unit. A higher viscosity index indicates that the lubricant is of higher quality. It should be emphasized that the viscosity index is in no way related to the SAE viscosity. It is determined based on the composition of the base mixture. In particular, for mineral-based oils, the viscosity index is in the range of 85 to 100 units. For semi-synthetics, it varies in the range of 120 to 140 units. Pure synthetics is characterized by a viscosity index at the level of 160 to 180. In practice, this means that motor oils with a low viscosity index, for example, 5W20, can be used in turbocharged engines characterized by a wide range of operating temperatures. To increase the viscosity index, binding additives are introduced into the lubricating fluid, the main task of which is to extend the temperature range of oil application. Thus, the higher the index, the more universal the oil will be. Classification of motor oils. The existing division of motor oils is associated with the diversity of their compositions. The following groups of classifiers are generally accepted, depending on the chemical composition of the lubricant: mineral, semi-synthetic. Synthetic oils, by viscosity index according to SAE standard, depending on the quantitative and qualitative composition of additives. According to ACEA/API classification, according to engine oil tolerances defined by car manufacturers. Each of the described groups does not provide a clear recipe which oil should be considered the best. The applicability of is a relative concept and depends on many factors, from climatic conditions in a given area to specific features of operation of a certain engine model. And it should not be considered that the latter is an unimportant factor. In fact, the technical diversity of automotive power units is so great that it can be called a determining parameter affecting the choice of oil. Engine volume, its design features, materials used in the manufacture of highly loaded units. All this has a direct impact on the possibility of using a particular composition of lubricant. And, as it happens in almost any field of engineering, improvement of one parameter has a negative effect on another. Let us explain the above on the simplest example. Budget cars at a crankshaft speed of 3,000 RPM develop a speed of about 100 to 120 km/h. Mid-level models at the same revolutions accelerate to 140 to 150 km/h. And for sports cars, this figure reaches a mark of 200 and above km/h. And do not be surprised that in all these cases you will need oil with different characteristics. How to know the viscosity of engine oil and other parameters depending on the specific case. It is, in principle, a non-trivial task. The solution to which this article is devoted. API standard. This classifier has a more venerable age than SAE. It was developed by the U.S. Fuel Institute back in 1969. According to this standard, motor oils are divided into 2 large subspecies: for gasoline-powered engines, for diesel-powered engines. Each of the subspecies is divided into quality classes. It is not without reason that this classification is called the oil quality standard. If belonging to a class is determined by the first letter of the standard designation, S, for gasoline, C, for diesel-powered power units, the second letter denotes the quality class. The closer the letter is to the beginning of the alphabet, the more obsolete class the given oil belongs to. At the end, there may be a number indicating for which motors the product is intended, 2-stroke or 4-stroke. If on the oil label there is no indication of its belonging to the API standard, it is either so outdated that it would be unwise to use it, or it is not certified according to this standard at all. Universal oils suitable for both types of engines are designated accordingly, with a /API/SJ/CF. Usually, the parameter that is more preferable comes first. With regard to the above example, this means that the oil is in principle intended for gasoline engines. However, its use in diesel engines is also permissible. It should be noted that the API class designation has nothing to do with the viscosity of motor oils. At the same time, the standard, despite its venerable age, is not static. The appearance of new additives leads to the formation of new quality classes. The last such modifications of the standard were made in 2006. Operating temperature ranges of according to SAE, since the viscosity of oil according to SAE is calculated under the operating temperature range. It is considered to be 100 to 150 degrees. It is clear that when starting a cold engine, especially in frost, the motor requires more effort to work to overcome the resistance of the liquid with increased viscosity. That is why all automakers, without exception, categorically do not recommend loading a cold power unit until it is fully warmed up, if the temperature outside is sub-zero. But even if you adhere to these recommendations, the procedure of starting a cold motor in a strong engine reduces its total resource by 250 to 500 kilometers, according to the statements of many experts. However, this is practically not reflected on the resource of the oil itself. There is also positive news. As the engine ages, the gaps between rubbing parts increase, which reduces the degree of influence of high-viscosity oils on the motor when starting it in frost. Read also, how to start a long idle car on a warmed-up motor. The parameters come into compliance with the operating temperature regime, and the output to the operating parameters occurs according to the following scheme. With increasing engine speed, the coefficient of friction also increases. The temperature of the oil itself increases due to the increase in resistance. Its viscosity decreases. The thickness of the oil film on the surface of the protected parts decreases. The coefficient of friction decreases inversely. This is accompanied by a drop in oil temperature. As a result, in any mode of operation of a warmed-up engine, over time the characteristics of the lubricating fluid become optimal. But this applies only to those temperature ranges that are characteristic of a particular power unit. In other words, the efficiency of the motor depends not so much on the viscosity of the lubricating fluid itself, but on the dynamic viscosity values at different temperature regimes. These, in turn, can vary greatly depending on the design of the power unit. It should not be forgotten that the efficiency of engine oil has a direct impact on a number of other important vehicle performance characteristics, including fuel efficiency and overall service life. Of course, if the coefficient of friction depends on the viscosity of the oil, the range of operating temperatures, and the value of clearances, then to determine these values of the average car owner cannot. And there is no need in it, because there is a table of viscosity of motor oils, which describes in detail their properties depending on the SAE class. And the European classification ACA even describes specific tolerances for motor oils depending on the viscosity/operating temperature. However, in the SAE classification, there is also a gradation for low and high temperature viscosity, and the latter is defined for kinematic and dynamic components. All these values are indicated in the table. We note from ourselves that a particular oil can be characterized by different viscosity values depending on temperature, and the number that is indicated in the product name after the letter W, with the real viscosity, is in no way correlated with the real viscosity. Unlike low temperature values, and kinematic and dynamic viscosity values are measured at specific temperatures, 100 and 150 degrees Celsius, and in intermediate modes the values may vary, and not always according to a linear law. To summarize the above, it can be stated that the viscosity index of is not in itself a criterion of its quality. What matters is whether the operating temperature ranges are suitable for a particular motor. Here is a table showing the measured viscosity values depending on the oil's SAE class. Class low temperature viscosity, MPa*SEC at temperature, degrees high temperature viscosity, crankability index, pumpability index, kinematic, measured at 100 degrees Celsius, MM2/SEC. Dynamic, measured at 150 degrees Celsius, and high surface velocity, MPa*SEC. Min-max 0W 6200.0, -35, 60,000.0, -40, 3.805 W 6600.0, -30, 60,000.0, -35, 3.8010 W 7000.0, -25, 60,000 indult, DOT. Ank 0, minus 30, 4.10, 15W, 7,000.0, minus 20, 60,000.0, minus 25, 5.60, 20W, 9,500.0, minus 15, 60,000.0, minus 20, 5.60, 25W, 13,000.0. 10, 60,000.0, minus 15, 9.30, 25.60, before 9.30, 2.60, 39.30, to 12.60, 2.90, 40, 12.60 up, to 16.30. 2.90, 0W divided by 5W divided by 10W, 40, 12.60 up, to 16.30, 3.70, 15W divided by 20W divided by 25W, 50, 16.30 to 21.90, 3.70, 60, 21.90, 26.10. 3.70, is it acceptable to mix of different viscosities? In the process of car operation, situations often arise that require refilling of lubricating fluid. And one of the main questions that many car owners are interested in is whether it is possible to mix oils that differ in viscosity, composition, or at least brand. The reasons for refilling oils or mixing them during routine replacement can be different. The possibility of saving money. Many drivers practice such a method as mixing part of the old with new engine oil, hoping that such mixing will not greatly reduce the replacement interval. If an unscheduled measurement of the level shows that it is below the MIN mark and the need to travel remains at a critical level. In such cases, the first grease that comes to hand is used. This allows you to get to the nearest service station without any problems. Of course, this method can be called extreme, and in most cases, after its use, a complete replacement of the fluid is required. But even if you completely drain the old oil during an oil change, some of it will still remain on some parts of the powertrain. And even flushing does not guarantee that you will not end up with a certain mix, albeit with a minimum concentration of the previous brand of oil. However, this option is usually not considered as capable of affecting the engine life in any appreciable way. In general, the problem of mixing oils with different viscosity grades is not a good idea. What happens if you mix oils of different viscosities? The point is that low viscosity lubricants, which we consider to be winter oils, when mixed with summer oils do not form a universal composition, the temperature characteristics of which are obtained by adding the viscosities of each oil separately. What will definitely happen is the reduction of both low temperature and high temperature components, and as a result, the stability of the oil film will suffer greatly. However, if the indices in the marking differ only by one step and only in relation to one of the two digits, we can talk about the relative admissibility of such mixing. If for your car native is oil 5W40, adding lubricant with marking 5W30 will reduce viscosity at high temperature mode of operation of rubbing surfaces of the power unit. Automakers in principle do not prohibit pouring oil that complies with the recommendations, but provided that at least at the level of viscosity classes, the old and refill oil will be compatible. So, topping up oil of a different viscosity is a method that should be used only if absolutely necessary. Usually car owners have leftovers of the oil they poured when replacing the oil, so this question is not particularly common. Which viscosity oil is better to choose? Much more interesting is the case of a complete replacement of the filling liquid. The counters of auto stores are literally flooded with lubricants from different manufacturers, with declared viscosity characteristics according to SAE. Theoretically, the choice of a suitable one should be reduced only to the choice of the appropriate viscosity index. But there are nuances here as well. And if we take into account that many users are sincerely convinced that the higher the index on the label, the better, then the problem of choice really becomes difficult to solve, and often the final decision is made with the help of an outside expert. If this person is not known to you personally, you should definitely refuse such advice, especially if he claims that by pouring sports oil into your vehicle, you will turn the car into a monster. In fact, everything will happen exactly the opposite. The engine power will drop, and its resource will be significantly reduced. Thus, You yourself will have to decide which oil viscosity is better, guided solely by the recommendations of the car manufacturer. In conclusion, understanding engine oil viscosity is essential for maintaining your vehicle's performance and longevity. By recognizing the significance of the numbers on the oil container, you can choose the right oil for your engine's needs, ensuring optimal lubrication and protection under various conditions. Remember, a well-chosen oil not only enhances efficiency, but also contributes to the overall health of your engine. Stay informed and make the best choices for your vehicle to keep it running smoothly for years to come. Thank you for watching, and drive safely.